Voltage drop is an important consideration when installing electrical circuits, especially for subpanels. It's crucial to understand how to calculate voltage drop, comply with the National Electrical Code, and explore options for mitigation. The formula for calculating voltage drop, or volts D, is volts D equals 2 times I sub L times L times D divided by AWG. In this formula, I sub L represents the load current measured in amps. L is the length of the wire, typically measured in feet. D is the distance factor, which is often one for a single-phase system. AWG stands for American Wire Gauge, which specifies the wire size. Now let's consider an example. Suppose a property owner installed over 200 feet of 1 and 1/4-inch Schedule 40 conduit from their residence to a detached garage. They intend to install a 100 amp subpanel using 2 AWG wire. The voltage drop calculation would be as follows: volts D equals 2 times 100 amps times 200 feet times 1 divided by the AWG value for 2 AWG wire. After calculation, it shows a 5.71% voltage drop. A National Electrical Code, or NEC, sets standards for electrical installations. According to the 2020 NEC, voltage drop should not exceed 5% for branch circuits and feeders supplying equipment. In this case, the calculated voltage drop of 5.71% is slightly above the allowable limit. Therefore, it's not advisable to proceed with the installation as originally planned. There are several options to address the voltage drop issue. Firstly, using a larger wire size can reduce voltage drop. For instance, upgrading from 2 AWG to 2/0 AWG would decrease the resistance and subsequently lower the voltage drop. However, it's important to consider whether the larger wire size is feasible within the existing 1 and 1/4-inch Schedule 40 conduit. Secondly, reducing the load on the circuit can also help mitigate voltage drop. This could involve using more efficient appliances or distributing the load over multiple circuits to minimize the current flowing through any single circuit. Thirdly, installing a transformer near the load can boost the voltage, compensating for the voltage drop along the wire. While this option may be more expensive, it can be necessary if other options are not feasible. Additional considerations include the type of wire insulation and the temperature of the wire. Different wire insulation types, such as THHN and XHHW, can affect voltage drop. THHN insulation typically has a higher voltage drop compared to XHHW insulation. The temperature of the wire also plays a role. Higher temperatures increase resistance, leading to increased voltage drop. Selecting appropriate wire insulation and considering temperature effects can further optimize the electrical installation. In conclusion, when dealing with voltage drop issues, it's essential to calculate the voltage drop accurately, adhere to NEC requirements, and explore viable options for mitigation. By carefully considering these factors, electrical installations can be optimized for safety and efficiency. Remember to consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Ignoring voltage drop can lead to several problems. Firstly, reduced performance of equipment is a significant concern. When voltage drops excessively, electrical equipment may not operate at its optimal level. Motors may run slower, lights may dim, and electronic devices may malfunction. This can lead to inefficiency, increased energy consumption, and premature failure of equipment. Secondly, overheating of wires and equipment can occur due to excessive voltage drop. As voltage decreases, current increases to compensate, causing the wires and connected equipment to overheat. This overheating can damage insulation, melt conductors, and create a fire hazard. Thirdly, increased energy consumption is a consequence of voltage drop. When voltage drops, electrical devices draw more current to perform the same amount of work. This increased current leads to higher energy consumption, resulting in higher electricity bills. Additionally, the increased energy consumption contributes to wasted energy and increased greenhouse gas emissions. Therefore, addressing voltage drop is not only essential for the proper functioning of electrical systems but also for energy efficiency and environmental sustainability. The National Electrical Code provides guidelines and regulations for electrical installations to ensure safety and proper operation. It's crucial to adhere to the NEC requirements when designing and installing electrical systems, including subpanels. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders to prevent the issues mentioned earlier. Complying with the NEC helps ensure that electrical systems operate safely and efficiently. When calculating voltage drop, it's essential to use accurate values for the load current, wire length, and wire size. Load current should be determined based on the actual or anticipated load on the circuit. Wire length should be measured accurately, considering the entire length of the circuit from the source to the load. Wire size should be specified according to the American wire gauge standards, ensuring that the wire is adequately sized for the intended load and length of the circuit. Using accurate values in the voltage drop calculation will provide a more reliable assessment of the voltage drop and help in selecting the appropriate wire size and other components for the electrical system. When exploring options to reduce voltage drop, it's essential to consider the feasibility and cost-effectiveness of each option. Using larger wire sizes may be effective in reducing voltage drop, but it can also increase the cost of materials and installation. Reducing the load on the circuit may involve using more energy-efficient appliances or redistributing the load, which may require additional wiring or circuit modifications. Installing a transformer near the load can provide a voltage boost, but it can also be a more expensive option. Evaluating the trade-offs between cost-effectiveness and feasibility is crucial in selecting the most appropriate solution for addressing voltage drop. In addition to the options discussed earlier, other factors can affect voltage drop. These factors include the type of wiring used, the installation methods, and the presence of voltage fluctuations or imbalances. Using high-quality wiring with low resistance can minimize voltage drop. Proper installation methods, such as avoiding sharp bends in the wiring and ensuring secure connections, can also reduce voltage drop. Monitoring voltage fluctuations and imbalances in the electrical system can help identify potential sources of voltage drop and implement corrective measures. Addressing these additional factors can further optimize the performance of the electrical system. To ensure that voltage drop is properly addressed, it's recommended to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to assess voltage drop issues, perform calculations, and recommend appropriate solutions. They can also ensure that electrical installations comply with all applicable codes and regulations. Consulting with experts can help prevent potential problems and ensure the safety and reliability of electrical systems. Consider the impact of voltage drop on sensitive electronic equipment. Electronic devices are often sensitive to voltage variations, and excessive voltage drop can cause them to malfunction or become damaged. For example, computers, servers, and other electronic equipment may experience data loss, system crashes, or hardware failures due to voltage drop. Therefore, it's crucial to ensure that voltage drop is within acceptable limits, especially when powering sensitive electronic equipment. Using voltage regulators or uninterruptible power supplies can help stabilize the voltage and protect electronic devices from voltage drop. Evaluate the long-term costs and benefits of addressing voltage drop. While addressing voltage drop may involve some initial expenses, it can result in long-term cost savings and benefits. Reducing voltage drop can improve the efficiency of electrical equipment, reduce energy consumption, and extend the lifespan of equipment. It can also prevent equipment failures and downtime, which can be costly. Therefore, it's essential to consider the long-term costs and benefits when making decisions about addressing voltage drop. Investing in solutions to mitigate voltage drop can provide a good return on investment over time. In addition to the NEC, other standards and regulations may apply to electrical installations depending on the location and type of installation. Local building codes, utility regulations, and industry standards may have specific requirements related to voltage drop. It's essential to be aware of and comply with all applicable standards and regulations to ensure the safety and legality of electrical installations. Consulting with local authorities and industry experts can help ensure compliance with all relevant requirements. Conduct regular inspections and maintenance of electrical systems to identify and address potential voltage drop issues. Over time, electrical connections may loosen, wires may corrode, and equipment may degrade, leading to increased voltage drop. Regular inspections and maintenance can help identify these issues early on and prevent them from becoming more significant problems. Tightening loose connections, replacing damaged wires, and servicing equipment can help maintain optimal voltage levels and prevent voltage drop. Incorporating voltage drop considerations into the design of electrical systems is essential for preventing problems and ensuring optimal performance. During the design phase, careful attention should be given to wire sizing, circuit layout, and equipment selection to minimize voltage drop. Using appropriate design techniques and tools can help ensure that voltage drop is within acceptable limits and that the electrical system meets the needs of the application. Collaborating with experienced electrical engineers during the design phase can help ensure a well-designed and efficient electrical system. Provide training and education to electrical workers and contractors on voltage drop and its effects. Electrical workers and contractors should be knowledgeable about voltage drop calculations, NEC requirements, and best practices for minimizing voltage drop. Providing training and education can help ensure that electrical installations are performed correctly and that potential voltage drop issues are identified and addressed proactively. Investing in training and education for electrical professionals can improve the quality and safety of electrical work. Consider the impact of voltage drop on renewable energy systems, such as solar and wind power systems. Renewable energy systems often involve long wire runs from the generation source to the point of use, which can result in significant voltage drop. Voltage drop can reduce the efficiency of renewable energy systems and limit the amount of power that can be delivered. Therefore, it's crucial to carefully consider voltage drop when designing and installing renewable energy systems. Using larger wire sizes, optimizing the system layout, and incorporating voltage regulation devices can help minimize voltage drop and maximize the performance of renewable energy systems. Addressing voltage drop is essential for realizing the full potential of renewable energy sources. When addressing voltage drop, it's important to document all calculations, decisions, and actions taken. Documentation provides a record of the design process, the basis for decisions, and the steps taken to address voltage drop. This documentation can be valuable for future reference, troubleshooting, and maintenance. It can also be helpful in demonstrating compliance with codes and regulations. Maintaining accurate and complete documentation is a best practice for electrical installations. Staying informed about new technologies and techniques for addressing voltage drop can help improve the efficiency and effectiveness of electrical systems. Researchers and manufacturers are constantly developing new products and methods for minimizing voltage drop and improving the performance of electrical systems. Staying up to date on these advancements can help electrical professionals implement the latest and most effective solutions for addressing voltage drop. Participating in industry conferences, reading trade publications, and networking with colleagues can help stay informed about new technologies and techniques. Remember that voltage drop is an important consideration for all electrical installations, regardless of the size or complexity of the system. Whether it's a small residential circuit or a large industrial power distribution system, voltage drop can have a significant impact on the performance and safety of the electrical system. Therefore, it's essential to always consider voltage drop and take appropriate measures to address it. Paying attention to voltage drop is a fundamental aspect of good electrical design and practice. By following these guidelines and best practices, you can ensure that your electrical systems operate safely, efficiently, and reliably. Addressing voltage drop is not only a matter of compliance but also a matter of professionalism and commitment to quality.